we learned how to install Kubernetes, that is EKS. Okay, so rather than saying EKS, I'll be saying Kubernetes most of the times. Okay, so we need some workload on it, right? We have created a cluster, but we need some applications, some pods are running on it. Okay, so there are two methods of running pods. Okay, one of them will be the imperative commands. Okay, the other one will be the declarative manifests. So as the name suggests, imperative commands will give the step-by-step instruction. These are the imperative commands used only for testing purpose. Okay, so this will create a deployment. Okay, and the equivalent of it, that is the YML file, is this one. Okay, so the difference between imperative commands and the declarative one is the manifest is the declarative command will start like this. Okay, its equivalent manifest. Okay, manifest we call whatever we write in YML format is called as manifest. This is the manifest, and I'll explain about manifest in some time, but let's first do our exercise. Okay, the first part. Okay, that is create the Kubernetes objects. Okay, the pod, deployment and service, these are called as Kubernetes objects. Okay, it organizes and manages resources. Okay, so what is pod and all we'll see, but let me first give a demo. Okay, then I'll explain all these things. So lab which we'll be doing here is create pod deployment service using imperative commands. So we have created the cluster. Okay, we can get it details. Okay. The cluster is created in US East and it is running fine. Now we can get the details kubectl get all. This command will be using most of the times. At least if we get this output, that means we are properly connected. Now we'll create our first pod. Okay, so in Docker as well, when we did what we did, we ran the command docker run, and what it did, it downloaded some image. Okay, like httpd or nginx. Similarly here we can run the pod. Okay, so instead of container, I'll be specifying it as a pod. So what I'm saying, run an httpd pod. Okay, name of the pod is httpd, and use image httpd to create that container or a pod. Simple. Okay, just run it. Okay, and it says that the pod is created. Okay, and it is created in a default namespace. We are in a default namespace. Just to kubectl get all, and we can see a pod is running now. Okay, till now we were able to see this only, that is about Kubernetes service, but now if you see, the pod is running. Okay, so what it did at the back end, it searched for httpd image from Docker Hub. Again here, by default, it will take it from Docker Hub image. Okay, it downloaded from the Docker Hub because this system is connected. Okay, or you can say the Kubernetes cluster is connected to the internet internally. Okay, and that's why it was able to go to dockerhub.com and download httpd image, and it is running the httpd pod now. Okay, now the pod is created, but how to access it? Okay, so there are various methods to access it. First method would be, let's go inside the pod and try to check what is running properly or not. So kubectl, okay, exec, okay, a bit similar to Docker. Going inside the container, execute an interactive terminal -it, okay, for this pod. Okay, and after that we have to use this bin bash. Sometime it will be bash, sometime it will be sh. Okay, if bash gives error, use sh. Okay, so if you see, we are inside the pod now. We are inside httpd pod. We can run some command. Let's see if ipa command is running. Okay, so it's not running. It's just like a container now. So the main aim is we have to first check curl localhost. Okay, the curl command is not found. So let's install it apt get update. So sometimes sudo command will not work. Okay, so don't try to add sudo. If it gives an error, remove that sudo. apt-get -y install curl curl. Okay, now try to access. You can see we know that Apache runs on port 80, so we are not adding port 80 after it. Okay, and if you see inside the container or inside the pod, the service is running. Which service? Apache service is running. So this is how we create a pod. kubectl get all. We have created a pod, we went inside it, and we are able to access the page. Okay, but we need the access from the outside world as well. Okay, so for that we'll have to create a service. Okay, without service we cannot access it. So service is nothing but some networking component. So there are various types of services. Okay, so let's learn one by one. So the first is we are doing everything using imperative commands. Okay, not the declarative approach. Okay, so this is the command which will. Okay, so what we are saying, expose the pod name is httpd pod. This is the pod, expose pod httpd. Okay, and we are creating a service, so shortcut service, and we will be creating a first type of service. There are 3 to 4 types. Okay, the first is cluster IP, so it's a shortcut it's CIP, and we are saying that on that service access it on port 80. Okay, just press enter, and if you see, it's saying that now this pod is exposed as a service httpd service cluster IP. Just use kubectl get all, and you'll be seeing one service running cluster IP. Okay, now within the cluster only this cluster IP will work. Okay, that means is DevOps VM part of that cluster? No. Okay, we are only interacting with it. So if I do curl here, curl with this IP to this IP, this is the cluster IP given to it. Okay, and remember this cluster IP is not the IP of the pod. Okay, pod will be having a different IP, and we have to create a service separately service to interact with that pod. And why separate service and not directly the pod IP, I'll explain it in some time. But as this is not part of the cluster DevOps VM, it will not give you the output. Okay, I mean this cluster IP is internal within the pods. Okay, so what we will do is so first we did it for cluster IP, similarly we do for others as well. Now what we will do, we'll again connect to one of the pod. We have only one pod. This is the pod. Okay, and this pod is a part of cluster. Okay, exec. We are inside the pod now. This pod, and this pod is a part of the cluster. Okay, so from here it should work. Okay, just do curl, and remember it is this cluster IP is working on port 80, and if you see it is working now, but from the pod. That means the pod to pod communication internally it will work. Okay, this will not work from the outside world. Still only for the internal communication the cluster IP is used. Okay, now let's create one more service, and that is the node port. Okay, so let's use this second command, almost similar to it, only the difference is we have defining here the type. Okay, for cluster IP, if we do not define the type, it will be considered as the cluster IP by default, but here we are saying it is a node port. Okay, we are defining a service as node port. Okay, we are exposing the pod, same pod with the name node port 80 it will use. Okay, and we have to give it a target port inside the container. It works on port 80. Okay, and we are defining that it is a type is node port. Now which node port? Node means both the worker nodes. Okay, so what it will do, it will make this service available on both the worker nodes port. Okay, so the service is created. Just check kubectl get all. Okay, so we have a pod. One of the service is cluster IP. Okay, and the next service is node port. But for accessing the node port, okay, we need to remember we'll have to use a port range which is defined here. Okay, so on both the worker nodes, this port is open for us to access it. Okay, 31119. Okay, so 31119 we can access. Okay, now how to get the IP of the ports? kubectl get nodes -o wide. Okay, hyphen get nodes will also give, I think, no, get nodes -o wide. Okay, so if you see, these are the IP addresses. Okay, these are the internal and these are the external ones. Okay, but external ones we will not use. Okay, mostly internal ones will see. Okay, because in production environment externals will be not means disabled. Okay, so even if we want to access it, I'll have to open the port and I have to access it. But here even 3.214 will not be accessible because it is not part of the DevOps VM. Okay, if it is part, then we can access it, because see, check what is the internal IP of DevOps VM. It is 172 something, and 172 will not interact with 198. Okay, so what we'll have to do, again go to our, this is only for testing purpose, go to our pod exec1. Okay, we'll go to the pod and we'll just do curl. It is accessible only on this worker nodes, that is the nodes. Okay, now this will work on this as well and the other one as well, only from within the pod. That means from pod network the communication is allowed. Okay, or if you have any other VM, okay, which is in this range, okay, then from that also we can access it. Okay, but it is not a good idea to expose the node port to the entire world. Only for testing purpose it is a good idea to use node port. Okay, but in the production environment we'll be using a load balancer. Okay, so the next service port we'll see is load balancer. Okay, but there is a catch, so I'll just log out again. kubectl get all. Okay, so if you see this one, you ignore it. There are two services. First one is cluster IP, the other one is node port. Okay, so the cluster IP, this is the cluster IP. For the node port, this is not the node port. Okay, you will all think this is a node port. No, it is not a node port. When the node port is created, only a port will be opened. Okay, 31119 in this case. Okay, this also we can hard code which port we want, but it randomly choose something from 30,000 to 32,000. Between anything between 30 to 32,000 it will choose randomly. Okay, and it opened that port on the worker nodes. Okay, it will still have a cluster IP, so this service has both a cluster IP and a node port. Okay, so most of the times if I ask you, you'll say this is the cluster IP and this is the node port. No, okay, both are cluster IPs. Okay, the only difference is when we create a node port, a cluster IP will be created, and along with that a port will be opened on the worker node. That's why it is called as node port. And which are those worker node? kubectl get nodes -o wide will show you the IP address of the both the node ports. So these are the node ports. Okay, and on those node ports 31119 is working. Okay, so again go inside the pod. Okay, and if you see curl, okay, this will work. Okay, this will also work. So don't think this is a node port. This is still a cluster IP, and for node port we'll have to use the particular node port only, 31119. So whatever concept I'm teaching, this is with respect to something called on-prem. On-prem will be mostly testing on the private IPs, right? There it is useful when it is not exposed to the internet or outside world. We can expose the node port, okay, the node itself. But in the production environment, it is not recommended. So by default, it will not even work. Let's try if it works. Curl. This is the public IP for that, right? So this will not work because then there will have to open port and all, and it is not recommended. This will not work. So we learned about two ports. Okay, one is cluster IP and other one is node port. Okay, now the third service which we'll learn is load balancer. Okay, so I'm now creating a third service, kubectl expose command. Okay, just do kubectl. Okay, get all. Okay, so the pod is running. Okay, one of the service is cluster IP. Then we created a node port. Okay, so as the name is, and this is the load balancer service which we created now. So again, the load balancer service will also create a cluster IP, but for the outside world, it has launched a AWS load balancer, elastic load balancer. Okay, so it will have a public IP, and this is the name given by it. Okay, so it will take some time. Okay, so if you see, this is the external load balancer for this pod, and now it will work. Let's check. If not, we'll try it in some time. Curl. It is not able to resolve. Just wait for some time, and we can also access it from here, browser. It will take some time. So at the backend, it is just provisioning that load balancer, and now it's, if you see, it works. So for the outside world, this is the one. Now I think from inside as well, it will work. So maybe the resolution problem, but it should resolve. So cat/etc resolve.conf. So some internal DNS servers it is using, and it will take some time for propagation. So from outside it is working. So we can also check its IP address. Online dig is one of the command. Okay, so if you see dig, just type it here, the name we want to get it a record, and if you see, it is the public IP, but it is given to that particular load balancer. I'm not sure it will give something. Okay, it will only work. Yeah, it works actually. So it is the load balancer which is assigned to that pod, and from the outside world we can get it. So here internally it is taking some time for resolution, so it's not giving it. Yeah, it started giving. So at the back end it is using two IP addresses. That's how the load balancers are configured. Okay, and if you see now curl, it works. Okay, now this is for first application. If you have 100 applications, there will be 100 load balancers. Okay, and if there are 100 load balancers, that means 100 public IPs, and if you from what I remember, at least 3,000 per month is the cost for one public IP address minimum. Okay, so that will cost us a lot. Okay, so there is a something concept called of ingress that will be seen tomorrow, okay, or day after tomorrow. But till now, just remember that as of now we can access any pod or a service, any pod using services. One on the is cluster IP. The cluster IP is for internal communications. If there are multiple pods, so within the cluster, the pods will communicate with each other using this internal IPs. Okay, and the for accessing it from the outside world, okay, or at least from network, we'll have to use node port. Okay, the node port means on a worker node it will open this port on both the worker nodes. Okay, and the last one is the load balancer, which we saw now. It will also create a cluster IP, and an external public load balancer will be attached to it to access it. So these are the three types of services. Now let's learn more about pod and all. Okay, so if, as I said, pod is the smallest deployable unit in Kubernetes. It represents one or more containers. In our case, there is only one pod. Okay, so what does that pod has? It has an image inside it. Okay, so in this image it is showing Docker image, but here we have used HTTPD image. Okay, the pod will have a container, one or more than containers, and it is having a Docker image running inside it. Okay, so we haven't learned about replica set. Okay, we haven't yet learned about deployment. Okay, that we'll see tomorrow. Okay, but we learned about services. Okay, so let me quickly explain services. I'll explain services again tomorrow. Okay, so to access this pod we need a service. Okay, and now the question would be why we are not accessing the pod directly. The pod will also have an IP address. Okay, but we are not accessing the pod directly because pod by default is ephemeral in nature. Okay, any container, or in this case pod, is ephemeral in nature. Ephemeral means when it get restarted the contents of it will be lost. Okay, or when the pod moves from one worker node to other worker node, its contents may get lost. Okay, so all the IP details are done via configuration files. Okay, those files will be also lost. Okay, that configuration file has details of IP and all. Okay, so the pod IP is temporary. The pod IP which it has is temporary. So next time when we try to contact that pod, okay, the IP will change and will get an error. Okay, so a static service is used. Okay, the services which we created now. Okay, it can be cluster IP, it can be node pod or a load balancer. In that we said that using this service contact the pod. So it is up to the Kubernetes and the service to contact the right pod. It maintains it internally. We don't need to take care of it. We just need to define a service, and using that service only we can interact. So on that service we open port 80. So on port 80 all those services were available. So if you see here, it's port 80, 80 and 80. Inside it is something else. So if you see, even the load balancer is opening one of the node port. Okay, and it's binding that to the port 80 of the service. Okay, so every time there will be cluster IP and node port when the node port and cluster uh, load balancers are created. Okay, so this is how it works. We need the service because the pod is ephemeral in nature. It will lose its IP address. Okay, that's why. And these are the service IP address services which we saw now. Okay, so how it was, the traffic comes to it on the particular port of a service. In this case it was port 80 when we created the cluster IP. Okay, and we all the time we did not define the target port, but if you can consider target port as port 80. So internally when first the traffic comes in, hits this service, okay, the cluster IP, and then it goes to the container internally. When in terms of node port, okay, here the directly, this is the traffic within the cluster, not from the outside world. Okay, here I have written traffic within the cluster. Now the outside traffic will come from on the node port, particular node port. Again it will go to the internal cluster IP, and when it is for the load balancer, a separate load balancer is created. Okay, from the outside world we access the load balancer. In this case, this is the one. This is the load balancer. It gave the, instead of IP, it gave some fully qualified name FQDN, and again it will access particular node port only. So if you see here, one more node port is open. So it manages internally how to contact that node port, and internally again the cluster IP. So again the cluster IP is also created, which is this one. In this case, for this load balancer, this is the cluster IP. Okay, and we internally interact with the pod. Okay, so this is also asked in the interview questions. What is the difference? Okay, so remember this diagram. This is very useful. So in short, we have seen how to deploy an application as well today on Kubernetes as well, but using imperative command. Tomorrow we'll see using declarative way, that is using manifest, that is YML as well. Okay, so for you all, I would suggest tomorrow, just by tomorrow, means create and delete it as well, create a EKS cluster. Okay, then do this lab, pod deployment and all, but only the imperative commands. Okay, only these commands only. There are some commands for deployment, this declarative as well. No, declarative is not there. Okay, that's fine. So this exercise you can do. Now I'll show you how to do the cleanup. First we'll do the cleanup at the cluster level, then we'll clean up the cluster as well. So kubectl get all. Okay, we'll give all the details. Okay, so we have one pod and 3 services. We can delete it. kubectl delete. Easiest option is just copy paste like this. Copy and paste. Pod is deleted. Okay, just do kubectl get all. We can see the pod is deleted. Let's delete the remaining services. Don't delete Kubernetes service. Even if you delete, it will not allow, but let's delete this one. Okay, we can write it on separately like this as well. Okay, now it has deleted all the services. So for load balancer, it will take some time. Okay, so if you now see kubectl get all, only one service is there. This we won't delete. Okay, so this cleanup is done at the inside the cluster. You can say the pods and services we have deleted. Okay, now using EKS CTL get cluster, we'll get the cluster detail. Okay, and now here you follow this lab, delete EKS cluster. Okay, so we can list the cluster. Okay, this is how we list the cluster, my cluster, or with get also we got the details. Okay, but here we got it in a JSON format. Then even in, we can list the node groups inside it. Okay, we created multiple node groups. So I was on some other page. This is, yeah, this is the lab. So if you see, we have a node group called standard node groups. Okay, so if you directly try to delete a cluster, it will not allow. Okay, first we need to delete the node group, and then we need to delete the cluster. And deleting a node group will also again take 15 to 20 minutes. Okay, do it only after you are done with the exercise. Okay, now it will give output in this format only. And if you see, if you run it again, so it will show the status as deleting. It is already showing status as deleting. Again I'll delete. Here press Q to exit here, and if you see, its status is deleting. And if you go to our console and check EKS, You can also do it from here if you want directly by going into cluster. We are in the cluster, then go to compute. In compute, here you can click here and click on delete. Select here and click on here delete. We have already done from the command line, this command. Okay, so it is up to you. You can do it from here as well. And after, when this is done, okay, it will show, it will remove it from here, and these two nodes will also be deleted. Okay, after that we can go to the cluster and delete my cluster by clicking here, or the commands are also given here. EKS delete my cluster. It will take 15 to 20 minutes, so I'll need to wait. Even if I do this now, it will not work. Okay, and after this as well, we need to go to this cloud formation. There also we need to delete this template, so I'll update this document in some time. Cloud formation, cloud formation, and we can delete these two stacks as well. So whatever at the backend, it creates some load balancer. Even for EKS cluster, it will delete some, it will create some security groups and all. That will also, it will try to delete if you delete both this, but do it after this deletion is completed, which is going on now. This one. Go to compute and we can see the deleting is still in progress. When it's done, okay, one of the node is already deleted. If you see here, one of the node is already deleted. When the second one is also deleted, we can delete the cluster.